And the square root of 23 is going to be plus or minus 4.796, and I'm going to go 3 decimal places. And then I'm going to subtract 3 from both sides. So I have x equals negative 3 plus or minus 4.793. Now that's really two different things. It's negative 3 plus 4.793. It's also negative 3 minus 4.793. So you have to do those separately. If I take negative 3 plus 4.793, I get 1.793. That's positive. And if I subtract it, I get negative 7.793. And those are my two solutions to solving that quadratic by completing the square. That's one way to do it. Okay, let's try another one. If I'm going to solve this by completing the square, first I'm going to move the constant over by subtracting it from both sides. So that gives me x squared minus 4x on this side and negative 10 on this side. To complete this perfect square trinomial, I'm going to end up adding a box. And whatever goes in that box, I'm also going to add to the other side. I take half of my b term, so half of negative 4 is negative 2. When I square negative 2, whenever you square a negative number, it becomes positive. So negative 2 squared is a positive 4, and that goes on both sides. This perfect square trinomial then becomes this binomial squared, and it's x, and whatever this half was, half of b was, goes in over here. On this side, I'm going to take negative 10 plus 4 is negative 6. To get to my x, I'm going to take the square root of both sides. But we know that we cannot take the square root of a negative number, cannot square root a negative number, at least not yet, so this would be no real solution. Okay, so be careful with that. So that's how we would do it if we were solving by completing the square. But we also have something called the quadratic formula. And before we get to simplifying it and use it in a really easy way, what we're going to do is derive or come up with what the quadratic formula is. And it's the same thing as completing the square. And I'm going to show you how to do it by using your process of completing the square to come up with a formula that you can apply to any quadratic that can solve any quadratic. So the first thing we do is we start with the standard form of the general equation. So the standard form is ax squared plus bx plus c equals 0. That's our standard form. And then first step we're going to do is we're going to divide each side or everything by a. So every single thing we're going to divide by a. And what we're doing is we're getting the x squared by itself. That's why we're dividing by a. If I divide by a here, the a's cancel, and that'll allow me to have x squared all by itself plus this is b over a times x plus c over a. And we know 0 divided by anything is 0. Now, just like when we were completing the square, I'm going to subtract my constant from both sides. So I'm going to subtract c over a from both sides. That's like moving your constant over when we completed the square. That'll give me x squared plus bax equals negative c over a. And just as an aside, if I need to take half of this, so 1/2 of b over a. Whenever you take half of something, you multiply it by half. That gives me b over 2a. So half of this, my halvesy, is b over 2a, and that's positive. To go in the box, like we normally do, I would square it. So this is going to be b over 2a, whatever that is, squared. And then I'm going to have b over 2a squared on this side. When I turn this trinomial into a perfect square trinomial, into a binomial squared, first part's x, and then whatever this half thing is, when I divide b by 2, that's b over 2a, that goes in the second part. And then on this side, if I have negative c over a, that part's easy. If I square this, I square everything inside, gets raised to that power. So this is b squared over 2 squared, which is 4, and then a squared. If I rewrite this side as one term, what I need to do is get a lowest common denominator, and my lowest common denominator is 4a squared. So when I rewrite this, this side stays the same, so I have x plus b over 2a squared equals, in order, if 4a squared is my lowest common denominator, this side's not going to change. But to get 4a squared on this side, I'd have to multiply a times 4a to make that 4a squared, which means I need to multiply the top by the same thing, which is 4a. And so now these both have a common denominator, 4a squared, and so I can combine the top. This is negative 4ac plus b squared all over 4a squared. And I haven't messed with this side over here yet, so that's b over 2a squared. I'm going to take the square root of both sides, and this is going to become x plus b over 2a, and I'm just going to flip around the b squared and the minus 4ac. Under this radical, I have b squared minus 4ac all over, I don't know what I was doing here, just not 4a, a squared is 4a squared, all over 4a squared. Now I can actually take the square root of 4a squared. I can't simplify this part, so that's all going to stay under a square root. So this is going to become x plus b over 2a equals the square root of b squared minus 4ac. But if I take the square root of the bottom, the square root of 4 is 2, the square root of a squared is a, so I can simplify that. But then that's a plus or a minus. Okay, remember when you take the square root, this should have been plus or minus here. Whenever you take the square root of a number, it's plus or minus. To get x by itself, I'm going to subtract b over 2a from both sides. So I end up with is x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Since this is the same denominator, I can just put it all over 2a and have, this is a negative, so negative b plus or minus the square root of b squared minus 4ac. And that, my friends, let me move that up, is the quadratic formula. Your quadratic formula is the x, your solution is always the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And the a, the b, and the c are all your a, b, and c from your standard formula. And we're going to use quadratic in the next lesson. This is just showing you how we come up with the quadratic formula.